I'll get this in. No, that's the whole chapter. This is the section heading.
No, I put chemical bond.
No, that's,
Really?
yeah.
Compound chemical bond?
Well,
That is
no.
formulas. That is formulas.
Oh,
That
yeah,
says
you did, yeah, you're
formula.
right, you're right.
Next.
Yep.
Let's do this.
All right, so here we're going to be spending quite a bit of time doing compounds, writing the formulas of those compounds, naming those compounds. We should probably give you a definition of what a compound is, even though we have used the word compound quite a bit up to this point, haven't we? It's chapter 19.
Because he took the first two out.
Why do you keep asking the same questions about bullets that you always ask?
Because you keep doing the same thing over and over again.
You're wearing the same
And I
shirt.
need something to do.
This is the same shirt?
Yeah, you wore it before.
What's wrong with that?
I've worn this
Bridget
jacket
is
every
down
single
one.
day.
I'm pretty sure you wore that jacket before.
Yeah.
I wear this
No.
every day.
No.
Look,
Mostly every day. Mostly, no. Not every day.
you look up.
Wow, that was quick. Yeah.
We need to make
No.
our sketchy note cards.
Yeah.
No.
my sketchy note cards.
Okay.
Are we gonna test over like what we've done in this chapter?
No, but what we have covered this chapter before the final will be on your final.
No!
Is the final just like a bunch of tests just stapled together?
I mean, I'm not taking the same questions from other tests. if
That's
what-
what Tyler does. He takes
Yours
it.
says
Perfect, great. How about Tyler?
Yours says we just stapling a bunch of
Okay, I believe in, doing things a little differently. Okay, so here's what a compound is. Okay? Anything that has two or more elements bonded together can be classified as a compound.
Correct.
So, compound is like your big heading.
Oh, big headed.
And compound can be broken down into two more specific things.
Yeah, we got that.
You should have this in a
Oh,
previous
isn't
chapter.
it? I know this one. No. Oh.
Molecule.
Molecule, and we talked about the other
No, wait,
portion.
pierce up and mix, oh, that's,
No. We talked about this.
element is the other one.
Nope.
ions. It's,
Oh.
We talked about this literally like 3 days ago.
I got you, bro.
Wrong one.
Start that out.
formula.
Protein.
Protein.
Yeah.
Formula doing it. I got it right.
Oh, I thought.
Where is my sharper? Oh, I found it. It's compound.
Did anybody know the difference between a molecule and a formula?
No, it's a ratio.
Hey, you.
It's true.
You there. Kramer.
What?
You gave us that, but you didn't break it down like that. You didn't break compound down.
Okay. Well, I am now.
Somebody else makes
Should
a
we turn up
Yeah, sure.
all the way back from the beginning of my notebook?
Oh, wait.
That is really the main difference.
All right then.
A molecule is a compound that is covalent. A formula unit is a compound that is ionic.
What if I did that?
And you have your brain.
I would never.
Okay? Now, it says has the same ratio of elements. What that simply says is a compound of water is H2O. Every time. I can't have water without 2 hydrogens and 1 oxygen. Okay? Because if you were to like put another oxygen in water and drink it, you die. Because H2O2 is hydrogen peroxide. You're probably like, I gargle hydrogen peroxide all the
I
time.
don't.
Or I'd put that on my owies.
On my
You guys know you're putting 3% hydrogen peroxide. 97% of that's water.
Ew, I put that on my boo-boo.
Let's go with this.
Okay, you don't have to put this in.
Yeah.
Don't put this in. I'm just gonna kind of give you a few common compounds. Okay, water, obviously, you know. This should also make sense. It's the most common compound on the earth.
Surface.
You could probably say on the entire earth. Yeah.
Surface.
But yeah.
Okay.
Silicate. Okay, the most common compound in the Earth's crust. What?
Look at this. We use pi to figure out.
Don't like this thing either.
Formula for a circle.
What the earth actually
Shape of a
does?
circle. The Earth has a crust just like pi.
405.
Okay, so glucose. We're getting a few bigger compounds here. Glucose. You should be familiar with glucose, right? Glucose is essentially just a form of sugar. Okay. Take biology, you'll learn quite a bit more about glucose through the photosynthesis process. And chlorophyll. Anyone know what chlorophyll is?
A whole bunch of
Cells. Cells. Yeah.
What kind of cells?
Chloroplasts.
And where are they
Plant
found?
cells.
Plants.
There.
Chlorophyll is what gives leaves on trees their green color.
Wow.
That's what she said.
What about the bark?
137.
That's brown.
It's a lot of atoms in that guy, right?
Yeah.
Okay. So that's just an example of glucose. Trying to show you a three-dimensional figure on two-dimensional paper, kind of difficult to see.
The black stuff is carbon?
Yeah. Okay, put this in.
Dang.
What?
Whoa!
Whoa! What?
Yep, do it.
A clock.
I will.
Should
I will not. And if I don't, I will fail when
The number that represents the number of the.
I just need to do something different. So I'm gonna do this.
You cannot do this type of stuff when the 8th hour people come
It can.
You tell me not to be me?
Oh.
in. I'm telling
It's on.
you, you're special, okay?
I am special.
But sometimes you're different kind of special.
I guess. Well,
We need to say the special for us.
you're not going to embrace the new students in as your family?
No.
No.
Guys.
Shane was
I mean,
happening
like
at.
when you adopt a family
Bad.
member, you need to embrace them. But we're not adopting
What are you doing?
them. They're just staying with us for a while.
There's foster kids.
Yeah.
So
Okay.
you still have to embrace them.
Make me.
Make your face.
What? Does that make sense?
Hey, Shane just gets roasted on his face.
But that one didn't make sense.
Totally did.
It's Mr. Kramer, everything makes sense.
Absolutely.
No, half the stuff he says doesn't make sense.
True.
Bro. Yesterday was crazy.
Man, I don't want to hear about you yesterday.
But he found a really cool
I really
Santa
don't.
video.
I could care less about you yesterday.
Well,
Okay.
That means that you could care less.
Yeah, exactly. I care.
Play Ultimate Baseball.
Ooh, that would be fun. Okay, keep this in. I want to talk about this. I love how it says the number that represents the number.
Hashtag.
I mean, you gotta, context is key here.
It's the pound sign.
Okay?
What?
the what?
That's a pound sign.
Y'all.
The hashtag that represents the hashtag of electrons. Hashtag science.
Okay, so it says the number that represents the number of electrons, so we're talking about how many electrons the atom in a compound either must gain or lose when bonding, essentially. It's essentially this. It's the charge that an atom gets when it bonds to form an ionic compound. So we've kind of done this already. So this should be not too difficult. Let me give you an example. Didn't we do something along the lines of,
Oh, the ionic dot notation.
yeah, didn't we do something along the lines of this? And we showed here, gotta give that, and then they create a charged ion, 2+, because it lost 2, and 2- because it gained 2. This is their oxidation numbers.
Oh.
Okay, also known as their charge when forming an ionic bond. Now, listen carefully on this. You can find oxidation numbers relatively quickly just by looking at the periodic table, similar to valence electrons. Let me explain what I mean. Okay? All of group 1, how many valence electrons does it have?
Oh, no.
One.
1, okay? When bonding, it has 2 options, right? Gain 7 or lose 1. And we said there's only one way that it's probably going to do. Lose 1, okay? What is its charge when it does that?
Positive.
Oh, it's positive.
Positive how many?
One.
That's its oxidation number.
Ooh.
It's essentially the charge it has when it forms its bond. Okay, so let's progress with that. How many valence electrons?
2.
2. What is its oxidation number?
2.
Plus 2.
Plus 2.
Why plus? Why is the plus so important?
Because it's getting rid of it.
Because it's
Yeah.
positive.
It's losing 2. Okay? We're gonna skip these guys for the same reason we skipped them when we were doing valence electrons.
Right.
Okay?
Three.
13. How many valence electrons?
Plus 3.
3. What's its oxidation number?
Plus three.
Plus 3. The whole group.
The whole group. All
Okay.
3 of them.
Ah, this is tricky.
Well, because it could go either way.
So group 14 is tricky because it has 4, so it could gain or it could lose 4. So it would be plus or minus 4. Could be
So
either.
could you do the number, so you could do 4 plus dash, not minus? Alright.
Yep.
Nitrogen also has
Yeah, you're getting into a much more deeper concept that I was hoping not to have to discuss.
Stop
with
it,
you.
Moira.
Come on,
You're
Moira.
acting like
You're,
Caleb.
you're making it more difficult. Okay, believe it or not, these guys have multiple oxidation numbers because these are the guys that bond covalently and they don't give and take, do they?
No, sir.
They share, so they have actually a variety of oxidation numbers, but we are going to just specifically deal with,
Oh, you have 2 of them.
we're going to specifically deal with their oxidation numbers when they form ionic compounds. Okay? So let's look at nitrogen. Okay, again, forming an ionic compound. How many valence electrons?
5.
5, okay? So lose 5, gain 3.
Gain 3.
Oxidation number is?
Negative 3.
Negative 3. Did you see what happened there?
Yeah.
Up to that point, we were kind of in the positives.
Correct.
Then there was a point where it's going to start gaining instead of losing, so therefore the charge or the oxidation number is going to start becoming negative.
Right.
Okay? How about this one?
6.
So, oxidation number?
Negative 2.
Negative 2.
Negative 1.
One.
Negative number?
0.
0. Okay?
Stable.
So, now look at these guys. Now let me know that. That's actually the oxidation number. And these guys always will be plus 1. These guys always will be plus 2. Most of these guys will be plus 3 except for this guy. But we're going to assume that ionically, when they bond ionically, they're only going to have one set of oxidation numbers. Okay, but we're not going to worry about the covalent oxidation numbers at this point. Okay, so plus 1, plus 2, skip a few, plus 3, plus or minus. I don't know if this helps, but red in your bank account is bad. It means like negative money. So we'll say this is where the negatives start. Negative 3, negative 2, negative 1,
Nothing.
0.
You broke.
Yes.
So,
Just broke,
I
boy.
feel like
It's
what
just-
you're trying to say is that we already learned all this stuff, you're just making it a lot, like the categories are just getting broke down and broke down and broke down.
Kind of. So what I just erased was showing ionic compounds. I'm hoping we're good with that, because now we're going to move on to the calculator version of it, if you will. So, you know, when you guys did the +2 and -2 and you found the charge, what you're really doing is finding the oxidation number. Now I'm assuming you got that down, that we can do things, do more deeper things, so we can do this quicker by just looking at the periodic table and say, oh, here's the charge. Here's the oxidation number, just by looking where it is on the periodic table. So if I say, what is the charge of magnesium when it bonds, you would say +2, and therefore its oxidation number would be +2.
Right.
Okay, and I will show you why that becomes important, because later we're going to write the formulas, and you need to have the oxidation numbers to do it. I don't know if I have time. I'll wait. I'll do that.
Rules for oxidation.
Woo! Lot. Just a few rules. Yes. Here's just a few rules of oxidation number. Okay. First one. This is the oxidation number of atoms in their natural form is 0. What this simply means is when not bonded, and you have an atom all by itself, we know that an atom has a charge of 0. So its oxidation number is 0. Okay, number 2, the oxidation number of an ion is equal to the charge. We talked about that too. If I've got a calcium in its stable ion form, it's going to be calcium 2+. That is also its oxidation number. That's what number 2 is saying. Okay? It says the sum of the oxidation numbers in all of the atoms in a compound must be 0. Let me show you what I mean. There is a formula unit for the guy you did on. Shoot, can't say that. Someone hasn't taken the test yet. Anyway, that is a formula unit. Okay? It says, number 3 is saying that the sum of these two oxidation numbers should add up to be 0. And why would it need to add up to be 0?
Because it has to be stable and it's, now I'm forgetting how to word
What did
this.
you say? It's neutral. Compounds are neutral, right? They don't have a charge. Okay? So I better have balancing out oxidation numbers so that I have balancing out charges. Let me show you what I mean. First off, what is the oxidation number of aluminum if you were to look at the periodic table? What about oxygen? So if I have 2 and each of them are 3 plus, what is how many pluses is that? 6. If I have 2 minus and I have 3 of them, 6 minus. So you got 6 plus and 6 minus. Those add up to give you
Nothing.
nothing. Here's what we're going to do with the future.
Someone says at the door. Lars. Why did you do that?
There's a relationship between those.
It's
And this is how we're going to quickly write formulas instead of doing aluminum, oxygen, showing the arrows where all the electrons go. We can get the formula unit by just having oxidation numbers. And we'll get into that as we progress. I know you're probably like, what exactly are you trying to show me here? We'll get there. Okay. Number 4, it says many groups regularly have the same oxidation numbers in compounds. Yeah, that's just kind of common sense. If you're in the same group, they have the same oxidation number. Right, group 2, what's its oxidation numbers?
Plus 2.
Okay, Sam, you look engaged. Not Sam, Shane. You look engaged.
Oh my goodness.
There's even a Sam.
Yeah.
Where did you get Sam
No
from?
idea.
Shane and Sam, they barely sound like two.
Okay, so lithium, oxidation number, what is it?
Lithium?
Li. Plus.
Plus 1. It's right there.
Carly, beryllium, Be, number 4.
Plus 2.
Ooh. Derek, fluorine. Don't overthink it. Look at the periodic table. Minus 1. Hey, here's another hint. There's no subscript here. It's minus 1.
Because there's
Yeah.
one iodine.
We'll get there. We'll get
It's
there.
just like math, full of letters.
But
Look
that's
at that.
aluminum.
Ethan, that's algebra.
I know.
Math,
We're
look.
going to start seeing how we write the formulas. The formulas can be quickly written by putting the oxidation numbers and crossing them down and forming subscripts. Because if I have a 2 plus charge and a 3 minus charge, I better have 3 of the positives and 2 of the negatives to get them to be canceled out to be equal, right? So you take their charges and you crisscross them down to get the formulas. We'll get there. Right. Let's keep going here. I think you guys got this.
Ow.
I just want you to put 1, 2, 3, and 4, and I want you to put the oxidation numbers above each of these elements. Can you do that for me? Quickly. Okay, above each element is each oxidation number.
Wait. That's not true.
Yep. I'll show you where. If you're gonna look at the subscripts to determine what the charge is, you have to uncrisscross. We'll get to that.
That makes sense.
It's not changing. Of what? Or did you look at the periodic table to find oxidation numbers?
Oh, yeah, it was a multiple,
So? What's sodium's oxidation number?
this one?
What's oxygen's oxidation number? What's calcium's oxidation number?
You heard me?
Yep.
+2.